Hello Year 10. So this is our final lesson in C 5.2 chemical analysis. And today we're going to be looking at something called emission spectroscopy. But let's start with a quick recap of what we've covered so far. So we have discussed that there are two types of chemical analysis. And if you could take these notes as we go through them. One type of chemical analysis is what we call qualitative analysis. The other type of chemical analysis is what we call quantitative analysis. Could you pause the video now and discuss the differences with your partner between these two types of analysis? Excellent. So what you should have discussed is that quantitative analysis is about how much, and qualitative analysis is about confirming the identity of a particular chemical. So if quantitative is how much, qualitative is what. What is it? And in this unit, we have already covered a number of types of qualitative analysis. Later on, in the next part of C5, in C 5.3 onwards, we will be looking at quantitative analysis. So far, we've looked at qualitative analysis. We started off by looking at melting point analysis. And what we learned is that a pure substance has a narrow melting point range, and that melting point is characteristic of a particular chemical. So by determining the melting point of a chemical, we can determine what it is. We then moved on to looking at chromatography. This was another type of qualitative analysis. And what we found out is that in a given solvent, the RF value, which remember is the distance moved by the spot over the distance moved by the solvent, is characteristic of a particular chemical. So chromatography can be used to test the purity of a substance. If, like in this example, we have more than one spot, then it's not pure. If, however, we had just one spot, then it would be pure. So you can determine if a sample's pure, but you can also determine the identity of a sample by comparing the RF value to a database. We also discussed some problems with chromatography. Pause the video now and discuss some of the problems and solutions with chromatography being used to identify chemicals. Excellent. So what you should have discussed is that different chemicals can have very similar RF values. So chromatography, using the RF value, is not always conclusive in terms of identifying a chemical. To solve this, we could change solvents, which would change the RF value, and check a database again. So we determine the identity of a chemical by comparing the RF to a database. Now, in the last lesson, previous lessons, we also looked at flame tests, which can be used to identify metal ions. And we're going to talk about more in this lesson linked to spectroscopy. And we also talked about other methods of chemical analysis, like precipitation reactions, to determine the identities of different chemicals. So that's what we've discussed so far. Our aims for today's lesson are going to be to find out what the difference between instrumental methods and non-instrumental methods are, and what the advantages of instrumental methods are. Now, sometimes non-instrumental methods are just referred to as chemical analysis or lab analysis. So it's experiments we could do in this lab today. We are also going to learn about emission spectroscopy and how it can be used to identify chemicals.